Welcome back. So in this session, we'll be dealing with magnetic effects of electric current. So these are the main equations in this topic. Biot-Savart's law, very important. dB equal to mu by 4 pi I dl cross r cap r vector divided by r cube and SI unit. See, so whenever you get a question, like, you will have a different option. Suppose you have to solve a Biot-Savart's equation. First check whether this is an elimination method. That is, in the options, if you see different units, means you can eliminate different options by seeing the unit itself. Okay, so SI unit of magnetic field is nothing but Tesla. So if they are not giving as unit as Tesla, you can just eject that particular option. Okay, so magnetic effect of electric intensity due to a straight current carrying wire. So B equal to mu 0 I by 4 pi r sine theta 1 plus sine theta 2. Then magnetic field intensity due to semi-infinite wire B equal to mu naught I by 4 pi r. Then infinite wire solenoid. Infinite wire solenoid B equal to mu naught I by 2 pi I. And for a solenoid, infinite wire this is semi-infinite wire. This is just infinite wire. B equal to mu naught I by 2 pi r. See, here you can see it is 4 pi r, here it is 2 pi r, and for a solenoid B equal to mu 0 n I by 2 sine theta 1 plus sine theta 2. So different magnetic field for a current carrying loop is mu 0 I by 2 r. Then current carrying circular loop mu 0 I by 2 r alpha by 2 pi. Axis of a current carrying loop B equal to mu 0 I by 2 r sine cube theta. Then magnetic field lines due to current carrying loop is like this, and toroid B equal to mu 0 Ni. So these are the different equation. I don't think I have to explain everything, but major equations, like all the laws you have to study, because definitely they will shoot questions which is related to particular law. So in some Lenz law or Biot-Savart's, Coulomb's law, and Ampere circuital law. So just like that, they will be shoot questions which is related to particular. So all the equation which is related to different laws, you have to be thorough. Here you can see Ampere circuital law, integral of B dot dl equal to mu 0 integral of I. And cyclotron, this is also some definite particular equation. So if one question is asked by cyclotron, you can shoot this equation. Okay, so I'm not going to explain all of them here, but we will directly go to how to solve a question, that is numerical problems. Okay, so in a certain arrangement, a proton does not get deflected while moving through a magnetic field region. Under what condition is it possible? So what I will say is, this is a theoretical question. Okay, so you can see that the magnetic force on a proton is nothing but QVB sine theta. Very important equation. So a proton moving parallel or anti-parallel in a magnetic field does not experience any force. Hence, the proton does not get deflected while moving through a magnetic field region, which means it can move without any effects of a magnetic field. So it is particularly the magnetic force on the proton will be obviously it will be 0. Okay, so your option will be A. Next one is, a wire placed along the north south direction carries a current of 8 ampere from south to north. Find the magnetic field due to 1 centimeter piece of wire at a point 200 centimeter northeast from the face. So what they have given is, like, they have given different angles. So from the question, what, as a student, you have to first pick the terminologies, as I said. Okay, so it is like, if you draw a figure, you can see that one direction is from south to north, like the straight line. So a fire is placed along a north south direction, that is a straight line. Suppose you are putting north south, like the point north south east and west. Okay, so north south direction, and the current of 8 ampere. So first current you got is like 8 ampere from south to north. Okay, then Find the magnetic field due to a 1 centimeter piece of wire at a point 200 centimeter northeast from the piece. Okay, 200 centimeter northeast direction is what, like this northeast direction. So your explanation for this one is dB is equal to mu 0 I dl sine theta by 4 pi r square. So this is a basic equation for a magnetic field. So dB equal to 4 pi into 10 to the power minus 7. Your current I is nothing but I is 8 into 1 into 10 to the power minus 2 sine 45. Since they have given it as northeast, your angle will be definitely 45 degree. Okay, so it is so r is what they have given, 200 centimeter. Very important, you have to convert it into SI unit. Okay, so all the SI unit you have to remember. Okay, so it is 2 square and dB equal to 1.1. If you solve this, you will get an answer that is 1.4 into 10 to the power minus 9 Tesla. Another one, a solenoid of 0.5 meter length with 100 turns. Yes. So here it is a solenoid. So directly you can go for the, or you can think about the direct solenoid equation. So what is a solenoid? So solenoid equation here is B equal to mu 0 Ni by 2 sine theta 1 plus theta 2. Okay. So that is the equation. So number of turns what they have given is 100 and 0.5 meter length carries a current of 5 ampere, that is I they have given. A coil of 20 turns and of a radius 0.02 meter carries a current of 0.6 ampere. So what is the torque required to hold the coil with its axis at a right angle to that solenoid in the middle point? So explanation you can see, like given mu is not equal to 4 into 3.14 into 10 to the power minus. So number of turns. So these are the terminology. So this is how you solve it. First write all the terminologies what they have given. So the number of turns of a solenoid is 100. Current passing through a solenoid is like 5 ampere. Then number of the turns of a coil is 20. Current passing through a coil is 0.6 ampere. Length of a solenoid is 0.5 meter. Radius of a coil is 0.02 meter. So magnetic field of a solenoid is mu 0 Ni, which is equal to mu 0 into is all the variables which you have got, you have to write it and solve it. Then magnetic moment of coil M, that is equal to current into area into number of turns. Okay, so 0.6 into what we have already got is 0.6 into 0.6. You can see current carries a current. So this is your ampere, and this is where is a, that is 0.02 they have given as an area. Okay, that is number of turns, and 0 and 20 is your number of turns. Okay, so torque is mb sine theta. So m you already got it, b you already got it. So mb sine 90 degree, that is they have given what we have to find. This is a torque at a right angle. So your sine 90 degree you have to give, and just solve it. You will get 1.89 into 10 to the power minus 5 Newton meter. Okay. Next is a long straight wire of radius x carries a steady current. The current is uniformly distributed across its cross section. Calculate the ratio of the magnetic field at x by 4 and 8x. So a long straight wire, so it is having a radius x carries a steady current, which means infinitely wrong where they are having a current. So the current is uniformly distributed across its cross section. Calculate the ratio of the magnetic field at x by 4 distance as well as 8x distance. So here the magnetic field due to a long straight wire radius x carrying a current I at a point at a distance r is given by B equal to mu 0 I r divided by 2 pi x square if r is less than x. B in is equal to mu 0 I by 2 pi r if r greater than x. So the magnetic field at a distance r equal to x by 4 is nothing but you, instead of x you will be putting, instead of r you will be putting x by 4. At 8x is you will be putting, instead of r you will be putting 8x. Then what you have to do is you have to just divide it. So b1 by b2 is equal to You will get the answer and your ratio will be 2. Two concentric coils of 20 turns each are situated in same plane. So their radius are 60 centimeter and 80 centimeter, and the currents are 0.04 and 0.05. Very easy questions. So respectively in opposite. Calculate the magnetic field at the center. Since the coil are concentric and in same plane, the carrying currents in opposite direction, the total magnetic field at the center of the concentric coil is given by B equal to B1 minus B2. So B, you know that our major, that is basic equation, mu 0 by 4 pi 2 pi n1 I1 by R1 minus B2 is mu 0 4 pi 2 pi into 2 pi n2 I2 by R2, where your R is your 60 centimeter and 80 centimeter, sorry, and currents is 0.04 and 0.5. Okay, so B is equal to mu 0 by 2. So you substitute all the values here and you will get 5 mu naught 6. That is 5 mu 0 by 6. Your B will be, so our option will be answer B. Okay, so this is small session about the magnetic fields. So I think, I hope you might have, please go and practice it. Like, if you hear the classes, that won't be like, you won't get full confidence to shoot a question. So in after reading or after listening to this, just go and solve the questions. Okay, so next session we'll deal with electromagnetic induction. Thank you.